Hello, now I will talk about the future electronics based on semiconductor technology. These are the contents. First, I will explain about the neuromorphic. Before that, there are about 100 billion neurons in the human brain. The brain transmits signals rapidly between neurons through synapses that connect neurons and processes and stores information. Neuromorphic is similar to this. This corresponds to a technology that mimics the brain with advantages such as performing recollection, calculation, and learning at the same time with a low energy, although it undergoes a calculation process with high speed. Neuromorphic can be largely divided into two groups, such as an artificial neural network and a spiking neural network, in terms of a method imitating the brain. In case of ANN, this is a statistical learning algorithm inspired by the neural network of biology. This is used in various fields such as image processing and machine language learning. On the other hand, in case of SNN, it directly imitates the structure of the brain to overcome the shortcomings of the present computer using devices such as memory registers. The memory register is a compound word of memory and registers and can perform functions of integrating memory and process. This is an optimal device for manufacturing a crossbar array that can effectively implement a physical artificial neural network inside a neuromorphic chip. Originally, it was only used as a digital non-volatile memory, but in the present, it is expected to contribute to the commercialization of the neuromorphic chip, which is an artificial intelligence computing chip that stimulates the human brain using memory research in analog form. However, unlike the points expected by the memory research characteristics, there are technical problems in which the memory research characteristic element needs to be solved until it is used in a real system. Looking at this picture, if there is a low voltage, residual resistance makes nonlinear characteristics. It is easy to use on the system when the change in resistance according to a constant voltage pattern applied to both ends is linear. However, it is difficult to use because it has no linearity and has nonlinear characteristics in a certain section. Therefore, it needs supplement. Also, there are some other semiconductor devices. SRAM is a silicon-based device that is proper to mass production and has high reliability. Also, the resistive RAM has a device using a material oxygen vacancy filament and a device using a cation channel. This is mainly used as a non-volatile memory due to the change in resistance by applying an external voltage pulse. There is also a phase change RAM. This corresponds to a non-volatile memory device that uses resistance change between the amorphous and polycrystalline state of a material through an external voltage pulse. Next is ferroelectric RAM. When an external voltage pulse is applied to a two-terminal ferroelectric film, the resistance is changed and used as a non-volatile memory. Also, when the external voltage is applied several times, the ferroelectric film changes little by little in analog form, so synaptic imitation is possible. There are already representative amor- there are already representative neuromorphic chips like IBM's TrueNorth and Intel's Loic. First, IBM's TrueNorth chip was developed by mimicking the constant changes in the SRAM-based synapse of the human brain, which showed great results in imitating the human brain. This is the logical view of TrueNorth. The TrueNorth architecture is composed of programmable neurosynaptic cores. Each core contains 256 inputs and 256 computational elements. Axons are connected to neurons through the programmable synaptic crossbar. Active synapses signify a connection from an axon to a neuron. The data communication between cores as well as with external components is carried out using spikes analogous to the binary signals that propagate information between biological neurons. Also, there is other neuromorphic chip. Intel designed Loi to provide the basic system for implementing SNN. Loi is a fifth generation and self-learning kinematic research chip introduced in November 2017. First is initial ideal state for time step t. Each square represents a core in the mesh containing multiple neurons. Then neurons in cores fire and generate spike messages. Spikes from all other neurons firing on time step t in cores are distributed to their destination cores. Finally, each core advances its algorithmic time step to t plus 1 as it handshakes with its neighbors through barrier synchronization messages. Besides, many companies like in Korea are also researching and developing the neuromorphic chips, which is the core next generation technology. Although there is a lot of work to do in order to achieve widespread implementation, with this neuromorphic technology, various things will be possible in the future. Memory implants, the first delete or create memory are possible. In particular, since the learning structure of the neuromorphic chip is similar to that of humans, it is expected to help greatly in the fields of voice recognition and image recognition too. Therefore, neuromorphic is very useful in the development of technologies such as big data and artificial intelligence. Thank you for listening.